Jai Shri Gurudev. Good afternoon, children. In this class, we will discuss something related to work and energy. In physical sense, all the activities such as working, reading, carrying a bag, and pushing a wall are all said to be work. For example, you just employ a worker, saying him to push a wall of high building. He tries his level best in doing so all over the day, but he doesn't able to push a wall little bit. Then even though he has not performed his work, he has put his labor in charge. Now, what would your answer be now? Definitely yes, because he has performed his task. Hence, you need to pay his labor in charge. But in physics, he has not performed his work, not at all. Then, what is the meaning of work in physics? The meaning of work in physics is totally different from the meaning of work in physical or general sense. So, work is said to be done only when the displacement is caused on a body. Then what is the displacement? So, take for example, this is the chalk holder. I am keeping this chalk holder on my hand. Now, the chalk holder is at rest because still I have not applied force. Just now starts to apply the force on this chalk holder. See, if you are applying the force on the chalk holder tends to move in the direction of applied force. So that means it changes from one place to another place of its position. So this is nothing but what? Displacement. So then displacement is nothing but changing of a place of an object from one place to another place only when the application of force. So this is called as displacement. So in case of work, the displacement is caused on a body, then only it is said to be what? Work is done by the body. So during what the displacement of a body is taken place means it is just because of the applied force. So how we are going to define the work in case of physics means? So keep in mind that before I told you that the work is said to be the product of applied force and also displacement of an object in the direction of applied force. So that means work is given by the product of what? Force into what? Displacement. Into displacement of a body in the direction of what? Applied force. Now, work is written as W, F is denoted as capital F, force is denoted as capital F, and displacement is nothing but what? Distance itself. Displacement is denoted by the symbol S. Now, the equation form of work is written as F into S, that means product of applied force and also displacement of the object in the direction of applied force. So here you need to keep concentrated on the three terms. One it is the work, another one it is the applied force, then next important term it is the displacement of a body in the direction of applied force. So next, in what conditions the work is going to be zero? So it's very important if you are applying a force on any object. So whatever the force you are applying, if it is able to displace the object, then only it is possible to say that work is said to be done by the body. Otherwise, work is not done by the body. On that situation, we need to consider work is equal to be zero. So this is very important. You need to concentrate here. Then, what is the SI unit of work? SI in the sense what? System of international. Totally we are having three systems. One it is the SI, next one MKS and CGS. CGS, MKS and SI systems already we have discussed in your previous class. Now, what is the SI unit of work means? So take the equation form. What is this? Force. The SI unit of force is Newton. That means force is measured in terms of Newton in SI unit, and the SI unit of this displacement is always taken as what? Distance traveled by the body. Hence distance is also measured in terms of meters. So totally SI unit of force is given by F is Newton and displacement is meter. So the SI unit of work is Newton meter, or this Newton meter can be written as joule. Newton meter can be written as joule. Hence the SI unit of work is taken as what? Joule. So this is very, very important. See, after knowing the meaning and formula of this work, we have to know where where we are going to apply the concept of this work in our day-to-day life situations. It's very important. By having this concept, it is not enough to fulfill the concept. We need to apply in our life situations. Then only it is possible to know the correct meaning of what this. Yes, by having the equation of work, shall we solve one problem over the work? So read the question. How much work is done by a force of 250 Newton in moving an object through a distance of 100 meter in the direction of force, right? So here what we want to calculate, say how much work. Say by reading the problem, we have to write the data first. Data in the sense what they given in the form problem. So what they given? How much work is done by a force of 250 Newton? Means they have given the force. How much force? Force is written as capital F, which is equals 250 Newton, and moving an object through a distance of in the sense what? So it displaces the object from one place to another place is nothing but what? Displacement. So it is recorded as capital S and it is given by 100 meters. 100 meter in the direction of force. By having this, we need to calculate the work done by the body. So work done by the body. So before going to solve the problem, you need to convert the units into SI system. So look at the data they given. Already force is given in terms of 250 Newton, hence there is no need of converting Newton into other form because already it is given in SI. And the displacement is also calculated in terms of meters. It is already given in terms of meters only. Now by having this data, it is very easy to calculate the work done by the body. Yes. Now write the formula. What is the formula to calculate the work done by a body? It is given by the product of force into displacement. Now substitute the values in place of the respective terms. The force which is equals to 250 newtons and the displacement value is given by 100 meter. 100 meter. So what is the value we will get? 250 into 100. 250 into 100. So 0, 0, 0. And next one 0, 5, 2. Totally it is 25,000. So 25,000. What is the SI unit of work? Work is always represented in terms of joules. So if it is a larger value, you can convert into short value, that is 25,000 means 25 into 1000 can be written in the form of its powers, that is 10 to the power of 3 joules. So this is the value of work done by a body in moving a distance of 100 meters by the application of 250 newtons of force. See, we can calculate easily by having all this data. Like this, you can calculate the work done by various objects in your day-to-day life situations. So after this, shall we discuss something related to energy? And the next concept is the energy. So in your previous classes, you have already learned about the energy. So here also very simple. What is the energy? Energy, it is the capacity of doing work. So energy is the capacity of doing any physical work is recorded as what? Energy. And what is the SI unit of energy? Means the unit used to measure the energy is once again same as that of the work. The SI unit of energy is the joule and it is denoted by the capital letter J. So under this we need to discuss mechanical energy also. So the concept it is what? Mechanical energy. So it is obvious that the energy in case of any object is either due to its virtue of its motion or by the position of a body. That means energy in a body is due to these conditions. What are the conditions? It is due to the position of its body or it is due to the virtue of its motion. These two conditions is considered to be taken as what? Mechanical energy. So that means what is the mechanical energy? It is the sum of kinetic energy and also potential energy. Now mechanical energy is broadly divided into one it is the kinetic energy, and the next one it is potential energy. So mechanical energy is broadly divided into two types. One is the kinetic energy and the another one is the potential energy. So what is the kinetic energy? The energy possessed by the body by the virtue of its motion. That means any object which are said to be in motion is considered as what? Kinetic energy. Kinetic energy in the sense moving body energy. The energy possessed by the body by the virtue of its motion is considered as what? Kinetic energy. Keep in mind that kinetic energy of any body is always said to be positive, and kinetic energy is taken as a scalar quantity. Then what are the examples of kinetic energy? We are having so many examples like a stone having some velocity, or a stone thrown with some velocity may breaks the window pane, or some moving vehicles if their collide leads to destruction, or flowing water, or it may be an arrow released from a bow, are all best examples of what? Kinetic energy. If you are generalizing or if you are giving an example for this kinetic energy, you need to be concentrate whether the example is in motion or it is in rest. If whatever the examples you are giving for this kinetic energy, if it is in motion, then definitely you can write under kinetic energy. So in this class we have to discuss something related to this kinetic energy. After this we will discuss potential energy. So now we need to find out the expression for kinetic energy, right? See, take for example an object. Consider this is an object having a mass m. So it's having some velocity v. It is having some velocity v. See, if a body having a mass m which is moving from here to here with some velocity v, the displacement has been taken place. The displacement has been taken place. That means an object is having mass m moves with a velocity v. That means it changes from this position to here with some velocity, and it is denoted as what? Displacement. So according to Newton's law of equation. So we are having three laws of equation in the Newton's third equation is v square equals u square plus 2as. This is the Newton's third equation which is used to derive the expression for the kinetic energy, right? So we know that v square is the final velocity. An object is already in motion. That means its initial velocity becomes what? 0. Again 2. Acceleration can be written as f divided by m according to Newton's laws of motion. Again s is written as same. Right? Now, again in simplified formula, v square equals, ignore the value of 0 because if it is a product we need to consider it is addition symbol is present, means just ignore the value where it's of no use. Then 2f divided by m into s. Now, again if we simplify, so we will get v square. This is m multiply cross multiplication we will get v square m which is equals 2 into f. Yes. So here we need to calculate f. So shift it to LHS. 2 f yes which is equals 1 v square m, right? Keep see again fs. So fs is written in the form of work. W equals fs because previously we have discussed that work is a product of force and displacement. Again see 2w which is equal to v square m. So write the w here itself, v square m. Transfer this to RHS, it will become denominator 2, or it can be written as w equals, take the 1 by 2 as common, 1 by 2 into v square m. See, work in the sense it is considered as kinetic energy which is equals 1 by 2. V square m is nothing but mv square. So this is the expression used for calculation of kinetic energy of any body. So Ke equals of mv squared is the expression to calculate the kinetic energy of any body. By using this formula, if we calculate one problem over this, we can know that where we are going to apply these expressions in our day-to-day life situation. The problem related to kinetic energy. We have already written the problem on the board. If a stone of mass 3 kg be thrown with the kinetic energy of 37.5 joules, find its velocity. This is the problem we got. We need to calculate its velocity. See, by reading the problem, collect the data first. See, the data from the problem is what they given. If a stone of mass of a stone is given by 3 kg, thrown with a kinetic energy Ke is given by 37.5 joules. Find its velocity. Find its velocity. See, by having this data, we need to calculate the velocity of a body. Now, write the expression for kinetic energy. Kinetic energy of any body is given by the expression of mv squared. Now, substitute the values in place of respective terms. So, the value of kinetic energy is 37.5 joules, which is equals to of, and the value of m is 3 kg. We need to calculate, write as it is. Again, go on simplification, cross multiply this. 37.5 into cross multiply 2, which is equals what? 3 into v square. 3 v square. So 2 5s are 10.27s are 14, 1 5, 2 3s are 6 1 plus 75.0, which is equals 3 v square. So as we need to calculate the value of v, transfer this total RHS towards the LHS. 3 v square equals 75, or v square equals 75 whole divided by 3. V square, which is equals 75 divided by 3. 3 2s are 6. 3 5s are 15. So we got the value of v in terms of its square. Just we need to calculate its value v. So write v here. Transfer the square root to RHS. So we will get the square root of 25 is 5. So SI unit of this velocity is meter per second. So the value of its velocity is 5 meter per second. So this is the value of what? Velocity of your body, which is having a mass 3 kg and its energy is 37.5 joules. So like this we can calculate mass, kinetic energy and velocity of any bodies in our day-to-day life activities. Try to have this practical knowledge by solving various kinds of problems. So if you are having any doubts regarding today's concept, you just have a call with me, or I try to clarify your doubts in a call. Thank you very much. Jai Shri.